Hi guys, my name is Farima Fattahi. I'm a first year master student at the CSE department and I'm a potential GSI for the ECS 388 course. In this lecture, we're going to talk about internet security with a special focus on the World Wide Web applications. These applications are prone to various attacks, and one common security threat that we're going to talk about today is called session hijacking. So as you know, nowadays more and more businesses are using the internet platform to offer their services, and hence the act of buying and selling products over the net is becoming way more popular. In this situation, financial and identity information are at a higher risk of being stolen. Sensitive data are constantly transported between sessions, and attackers are putting their best effort to steal them. The outline of the unit is as follows. First, we're going to talk about the technical details of the World Wide Web applications. Then we're going to see how web applications maintain ephemeral states that are short-lived and non-persistent. These states aid servers to keep track of the interactions with their clients. Unfortunately, the sloppy use of these features can lead to various attacks such as session hijacking, cross-site request forgery or CSRF, and cross-site scripting or XSS. Throughout this unit, we will look at the session hijacking attack and the defenses against it. So let's review the basics of the World Wide Web. Web applications consist of two participating components that are the client and the server. Clients are user agents such as laptops, cell phones, iPads, to name a few. Clients run browsers such as Chrome or Safari to connect to the internet and get the contents that are provided by the servers. These contents can be shopping websites, scientific websites, web blogs, and so on. Web servers has many types. The most popular one, as you can see in this image, is the Apache HTTP server. So what will happen is that a user who might be viewing a web page clicks on the web page link. As a result, an HTTP request will be issued that contains the URL of the resource that the client desires to obtain, along with some headers that are information about the client or the resource to be fetched. Web server receives this request and acquires the requested page from its database. Then it will send back this resource file in a HTTP response packet. The HTTP response packet contains a status code, headers that are information about the server or the resource file, data that is the resource file in the HTML or PHP format, and cookies that we will talk about them in more detail. The client or the browser will get this file and renders the file and shows the content of the file to the user. So what we have seen in the previous slide was one single interaction. A client sends a request to the server and the server responds with the corresponding information. But what if the client wants to have multiple interactions with the server in which each request depends on the previous responses from the server? A sequence of request-response pairs from one browser to a website is called session. Sessions can be long, such as Gmail that is 2 weeks long, or short. But however, HTTP is stateless, meaning that it has no notion of a state or memory. A request-response pair are completely independent at the protocol level. So how is it that we don't need to provide login credentials at every page load? The answer is that web applications maintain bits of state to keep track of interactions in one session. So we might notice that when interacting with a website, there are two kinds of state that should be stored. First, the long-lived state of the client, such as its profile information or credit card number, that is stored at the server's database. And second, the short-lived state that the web applications maintain in order for the clients to have interactions with the servers. There exists lots of information, lots of options for storing these states, and here we focus on cookies. So first, as a user sends a login request along with his or her login credentials to the web server. On successful login, the web server will generate and store a trusted state that is indexed by a cookie. Then the server will send back this cookie along with other information in the HTTP response. Finally, the client will retrieve this cookie and stores it in its hard drive locally. For other subsequent messages, the client will include this cookie in the message to the same server. So here is what a cookie looks like. Cookies are key value pairs that are set in the setCookie attribute of the HTTP response header along with other options. These options can be the expiration date, or they can be some flags such as secure that we will discuss later. So cookies are commonly used as session identifier. Websites use cookies to avoid reauthentication and personalize the websites based on the user's preferences. So the holder of a cookie can have access to the website with the privileges of a previously authenticated user. In this case, cookies are important capabilities that should be protected against adversarial attempts. Otherwise, attackers can steal these cookies and impersonate the legitimate users. This action will expose the user's personal information and account functionality to the adversary. So for understanding how a cookie can be stolen, we should consider the places that the cookie can show up. So as we already see, cookies are first generated at the web server, then transmitted to the client, and finally stored at the browser's disk. So, if an attacker can compromise the server or the client system and have access to the cookies, he or she can copy these cookies and have them for the further use. Also, if the algorithm that the server is using for generating the cookies is weak and simple, the attacker can predict it based on a few observations. And finally, if the attacker who is sniffing a network captures an HTTP packet that is not encrypted, he or she can retrieve this cookie and log into the website with the victim's privileges. This action that we call man-in-the-middle attack can be avoided by using secure HTTP that is called HTTPS. In this way, we can encrypt sensitive communications. So to protect the website against this attack, we can choose cookies that are sufficiently long and avoid using weak and simple algorithms for generating them. Also, we can set the secure flag for cookies in the setCookie field of the HTTP header. So as you can see in this image, the secure flag has been set, and so the cookie is encrypted and the attacker cannot access it easily. Moreover, as you can see in the setCookie attribute, we can time out session cookies using the expiration dates. And finally, we can issue a new session cookie at each login in order to shorten the living period of a cookie. So now, if the previous defenses were not successful in protecting the cookie from being stolen by the adversary, the session hijacking attack can be further defended against using not only cookies to identify a user's session. For example, if we could conclude secrets in the messages that are being sent to the servers in the form of, say, hidden form fields, or if the secret can be embedded in the URL and the server only processes the messages that have these secrets embedded in them, the attacker would fail to perform session hijacking. Moreover, some frameworks such as Ruby on Rails framework can help produce web pages that have these secrets automatically embedded in the links of their web page. Also, we can set the referrer field in the request header. As you can see in the picture, referrer is an attribute that refers to the URL of the website from which the request was issued. So if the servers force the browsers to set this attribute and only accept requests due to legitimate interactions that the users had with other websites, this attack can be avoided. So we found out that cookies are implemented for session management, and attackers can steal these cookies and impersonate legitimate users. However, this session hijacking attack can be prevented by first using unpredictable cookies and then rely on information other than cookies to identify a user session. In the next session, we will discuss other security threats such as CSRF or XSS and defenses against them. If you have any questions or there exist any gray areas, you can ping me on Slack or post it on Piazza. Thank you for your attention.